Download this code from codegive.com, link in the description below. I can't physically generate an image-based output of numbers 1 to 1000 in 100 different fonts within this text-based format. That would require image processing capabilities. However, I can provide a textual representation of the concept, a Python code snippet to demonstrate font variations, using a simple example and available fonts, and then discuss the broader idea of beautiful numbers and how different font choices might influence that perception. I'll also give you links to tools and libraries that will allow you to visually generate what you requested. Part 1: Understanding beautiful numbers. The concept of beautiful numbers is subjective and can mean several things. Mathematical beauty. Some numbers are considered beautiful due to their mathematical properties. Examples include prime numbers, numbers divisible only by 1 and themselves, example 2, 3, 5, 7, 11. Perfect numbers, numbers equal to the sum of their proper divisors, example 6 equals 1 plus 2 plus 3, 28 equals 1 plus 2 plus 4 plus 7 plus 14. Fibonacci numbers, numbers in the sequence where each number is the sum of the two preceding ones, example 1, 1, 2, 3, 5, 8. Golden ratio, phi related to the Fibonacci sequence and often considered aesthetically pleasing. Approximate 1.618. Numbers close to multiples of phi might be considered beautiful. Palindrome numbers, numbers that read the same forwards and backward, example 121, 353, 9009. Aesthetic beauty. This is where typography comes in. The way a number is represented visually can greatly impact its perceived beauty. Factors include font choice. Serif fonts, like Times New Roman, have small decorative strokes, while sans serif fonts, like Arial, are cleaner. Script fonts can look elegant but may be harder to read. Font size. Affects legibility and prominence. Font weight. Boldness, italics, etc., impact the visual impression. Color. Contrast and color palettes contribute significantly to aesthetics. Spacing. Kerning, space between letters/numbers, and leading, space between lines, are crucial. Arrangement. How the numbers are laid out, example in a grid, a spiral, randomly, affects visual appeal. Part 2: Python code, textual representation of fonts. Since I can't draw fonts, I'll provide code that demonstrates how you might access and list fonts on your system. This code uses the matplotlib library, primarily used for plotting, but also provides access to available fonts. You'll need to install it. Here's the Python code. Explanation. 1. Import libraries. Matplotlib.font_manager is used to find available fonts. Random is used to select fonts randomly for demonstration. 2. List_fonts, function *. Iterates through the font manager's font list, matplotlib.font_manager.fontmanager.tflist. Extracts the font name, f.name, for each font. Returns a sorted list of font names. 3. Generate _number _with _random _font, function *. Takes a number and the list of available fonts as input. Uses random.choice, to pick a font randomly. Returns a string containing the number and the name of the chosen font. This is a textual representation, not a visual rendering. 4. If __name _equals __main __::::::::::::::::::::::::::::::::::::::::::::::::::::::::::::n block *. This is the main part of the script that runs when you execute the Python file. It calls list_fonts, to get the list of fonts. It prints the number of fonts found. It loops through the numbers 1 to 10, you can change this range. For each number, it calls generate_number_with_random_font, to get a string representation of the number with a random font. It prints this string. It also shows an example of using the perfect number 28 with a specific font, but only prints it if the chosen font is present on your system. Important considerations * font availability * the fonts available on your system will vary depending on your operating system and installed applications. Textual representation * this code does not visually render the numbers in different fonts. It only prints the number and the font name. To generate actual images, you'll need a different approach, see Part 3. Error handling * the code includes a basic check to see if any fonts are found, but you could add more robust error handling, example handling cases where a specific font is requested but not available. Part 3, Generating visual representations, external libraries and tools. To actually visualize the numbers in different fonts, you'll need to use libraries that can handle text rendering and image creation. Here are a few options. *pill/pillow, Python imaging library, a powerful image manipulation library. *installation * pip install pillow. *explanation * 1 Import libraries * imports image draw and image font from pill. 2 Generate _image _ with _font, function * takes the number, font path, and output file path as input. Tries to load the font using image font.trueType. Handles I/O error if the font cannot be loaded. Creates a new RGB image with a white background. Creates an image draw object to draw on the image. Uses draw.text, to draw the number onto the image using the specified font and color. Saves the image to the specified output path using image.save. 3 If __name _ equals _main ::block *. Sets the font _path variable to the path of your desired font file. You must replace this with the actual path to a font file on your system. Font files typically have a .ttf or .atf extension. Calls generate _image _ with _font, to generate an image of the number 123, example, using the specified font, and saves it as number _arial.png. *keypoints *. Font paths * finding the correct font path is crucial. The comments in the code provide hints about where fonts are typically located on different operating systems. You can also use matplotlib.font_manager.findFont, Arial, to find the path programmatically. Replace Arial with the font name. Font size * adjust the size parameter in image font.trueType, to change the font size. Image size * you may need to adjust the image dimensions in image.new, to accommodate the text properly. The example attempts to automatically size the image to the text length, but more robust calculations may be necessary for complex layouts. Color * change the fill parameter in draw.text, to set the text color. *report lab, PDF generation if you need to create a PDF document with numbers in different fonts. This is more complex than pill for simple image generation. Other libraries Cairo, FreeType, lower-level libraries. Online tools many websites allow you to generate images with different fonts. You can upload or type in your text and then download the image. Search for online text-to-image generator or font preview tool. These can be good for quick experiments. Canva and similar design tools also offer good font options. Part 4, Automating Font Variations, and the 1 to 1000 Challenge. To generate images of numbers 1 to 1000 in 100 fonts, you would adapt the pill/pillow code, or use another library, to do the following. 1. Get a list of fonts *, use matplotlib.font_manager.fontmanager.tflist or a similar method to get a list of available fonts. 2. Select 100 fonts *, randomly choose 100 fonts from the list, or create a list of specific fonts you want to use. 3. Loop through numbers and fonts * use nested loops. 4. Generate images * inside the loops, call the generate_image_with_font function, or your equivalent, to create an image for each number and font combination. Make sure to generate unique file names for each image to avoid overwriting. 5. Handle errors * include try, except blocks to catch errors that might occur when loading fonts or generating images, example if a font is corrupted or doesn't support certain characters. Important considerations for the automated process *. Time generating 100,000 images, 1000 numbers * 100 fonts, will take a significant amount of time. Optimize your code where possible. Disk space * the images will consume a lot of disk space. Font availability * make sure all the selected fonts are actually installed on your system and that the paths are correct. Unicode support * if you need to support numbers in different scripts or languages, ensure your fonts have the necessary Unicode support. Naming convention * use a clear and consistent naming convention for your image files to make them easy to manage, example number _123 font _arial.png. The code example above does this. Part 5, Subjectivity and Beauty. Remember that beauty is subjective. What one person finds visually appealing, another might not. Some general guidelines for creating aesthetically pleasing number representations. Legibility * prioritize fonts that are easy to read, especially for smaller font sizes. Consistency * if you're presenting a series of numbers, maintaining consistency in font weight, style, and spacing is important. Contrast * use colors that provide good contrast between the text and the background. Wit space * don't overcrowd the image. Leave enough wit space around the numbers. Purpose * consider the purpose of the numbers. A formal report might call for a more traditional serif font, while a casual design might allow for more playful fonts. Experiment with different font combinations, colors, and layouts to find what you consider beautiful. In summary, you can't achieve the image-based output you requested directly in this text-based response. However, I have provided a comprehensive explanation of the concepts, a starting point Python code example, using Matplotlib for font listing and pill/pillow for image generation, guidance on automating the process, and considerations about aesthetics. Remember to install the necessary libraries, adjust the code to your specific font paths, and be prepared for a time-consuming process if you attempt to generate a large number of images. Good luck.